Okay, welcome to TDD.Academy. I'm your host, Lancer Kind. Over there, or I should say, over there, is usually solopreneur David Kuntz. But today he's got an appointment, so he could not join us today for the live stream. So I will be playing both roles. That was weird. I was hearing myself on YouTube there for a minute. It was a little bit of an echo. Okay, folks. So yeah, if you're interested in listening to some great jazz band that includes a violin that was by foreigners in China. This is this band here on SoundCloud called Nangua Bing, Nangua, and then Bing. Nangua Bing. Cool band. They got a few albums up here. All right, so let's go talk about our kata. Oh, before I get too far, I should share with those on the internet the dojo that we're using today. It's the same dojo we used last week, so if you were following along and care to enter into the Cyber-Dojo, you can drop right in. I see Encore is coming. Hey Encore, you're on mute, bud.
Yeah, hi Lens, how are you doing?
Good. Let me see if I can get you on camera here. I know you're blank screen right now, but let me at least... Hang on a second, I'm caught between two things.
I'm afraid your camera is also off on Zoom.
Oh, yeah. That is fine. Can run two cameras. All right.
Yep, I can see you now.
Now, I got to get you on camera. But first, let me get the Cyber-Dojo code out there. Not the code, but the link in case folks wanted to follow along. Folks, if you've joined this, if you see this code in the future, it probably won't work because the Cyber-Dojo will be recycled by then. But if you go back to episode 1, you can learn how to set up your own Cyber-Dojo. Let's see. Let me drop this into YouTube. Into the YouTube chat somewhere. TD.Academy. And I get to hear myself for a moment. Wow, how come I don't see the comment section? Oh, it's over here in the chat. Usually this is David's job, so I don't usually have to do this. Okay, LinkedIn.
Yeah.
Where's my LinkedIn? And so are you listening to yourself on the live stream too?
Yeah, I listened last time.
I mean, it's a little...
It
To
went
hear
well.
yourself echoing later, you can hear me faster over Zoom.
Yeah,
All right, cool. So,
yeah, I guess you're far better than me in this.
all right, I gotta get this out of the way. Done with all of that. And okay, let me take a quick look, see if I get you on camera. If I don't get it quickly, I will probably abandon that, but let's see what I got here. I got a guest over here. Getting the cameras working is usually a struggle. We try to do a little off before the show starts. But, okay. That did not solve the problem. Let's find you. I have a dream someday this will be easy to do in OBS, but it certainly is not easy today. For the last few years. Ah, there you are. All right, cool. Now I can get you framed in. Yeah, for some reason, OBS is not very good at this part. Our technology just isn't quite good enough. We have to constantly fiddle with things. And, oh yes, I gotta share my screen on Zoom. That actually might help with my camera in here. Okay. I'm sharing to the internet, but I'm not sharing to Ankur. By the way, Ankur, introduce yourself to the audience.
Yeah, hi guys. So, um, my name is Ankur. I've usually worked as a full stack developer in .NET technologies. And yeah, I'm here to learn about TDDs and how well it can perform on the long scale projects.
Yeah. Let's see here. Almost got to get this reframed. I see me on there twice right now. Okay, come on, you rascal. How am I doing here? Full screen. That's weird. That's not looking right at all. Okay, maybe that'll work better. Oh, I see. I gotta get this switched. One of the challenges is there are many ways cameraing goes wrong. And let's turn off my self view. And let's get Ankur on. Hey, Ankur, say something again. I got to get you back on camera. Zoom took you off. Just say hi. Uh-oh, Ankur, did I lose you? I think I lost Ankur. Well, that didn't work out very well, folks. I guess I don't need to worry about that until he comes back. Okay, anyways, hopefully Ankur will get back to us, and then we'll see if the camera just magically puts him where he's supposed to be. Always doubtful, unfortunately. All right, let's get on with the dojo. See if I can find that window I had all warmed up. And 100 doors, Kata. And not that one, but it's this one. Cool. All right, so last time on the show, what we got is we have 13. Do we have 13 tests? Is that what that means? We have a counter here. I don't know what all these lights mean yet, but anyways, we have some tests. We have a bunch of hallway functionality. And last time on the show, we built this loop to check for the every third door. Don't need this code anymore. And those of you who aren't familiar with this kata is about having 100 doors right there. And the question is, it's a mathematical, sort of a mathematical quiz, it's a puzzle, is if you flip every door, if you walk through all the doors in one pass, and you flip every door, you will have, okay, they all start out closed, and you flip them all, you go through and you flip from 1 to 100, you flip them all open, all the doors will be open, right? Then if you make a second pass and you flip over, you toggle from any door that's open, you close it. Any door that's closed, you open it. But if you toggle every other door, and then you do every third door, and then you do every fourth door, and by the time you get to the 100th door, where you just go to the last door and you toggle it, what will be the final state? And this can be solved mathematically, which David and his best friend Malibu have an answer. I have an answer too. I said it's 50-50. 50% of the doors will be open, 50% will be closed. Probably wrong, but I used a deduction by starting with a small set and said, well, if it works for the small set, maybe it'll work for the big set. It's generally a flawed logic. You can't assume everything works with that type of deduction, but that's all I had at the time. And David came up with a more sophisticated idea, and he's probably right. And he wrote his answer somewhere in here. David's rationale for predicting 10 doors are open. He says there'll only be 10 doors that are open. Okay, and he used more of a number theory approach, which sounds very logical and right to me. So let's soldier on and see what the computer tells us, because we have computers. Because the mathematicians, you'd say like, well, what about 1,000 doors? And then that guy's busy for a long time. And then he has the answer, and then he can like lord that over the other people. I don't know if you've seen Math Duel on YouTube, but it's a thing, man. Back in the day when there were mathematicians, their domain was like a certain village area, and they were the baddest math guy in that area. And if they got ousted, boom, they lose their job, and the other mathematician takes their place. Called a Math Duel. So check it out on YouTube, Math Duels. It's pretty cool about the history of math and how people outdid each other and kept secrets from each other in order to successfully win the math duels. Okay, so the only test that's missing. So we talked on the last show about just running it through all of it. What we do is we prove each little piece of this functionality works, and then we run it through all of the doors. And then my assumption is that if I correctly code each little piece, the whole thing will work together. There's one more test I want to do to make sure the whole thing works together. I mean, we have toggle a door, we can get the door status, we can run a traverse, which means we go through the hallway once, toggling the doors. We can traverse more than, we've test traverse twice, but I believe, and then we've skipped to different levels of traverse. We did a traverse 1 and a traverse 3. We've only done traverse 3, and we've done a traverse 2, we've done a traverse 1. But what we haven't done, folks, is we haven't done a traverse 1 and a traverse 2. I expect them to fully work, and then if traverse 1 and traverse 2 work in a sequence, in a test, then I'm going to use, again, deduction, and I'm going to deduce that if it works for those two, it's going to work for all up to 100. And then we'll get our result, and then we'll see what we have on the show. We'll have to look it up on the Google and see what the answer is. Okay. So let's try this. We are going to write a new test, do a couple traverses. So traverse 1, then 2. So the first traverse will toggle all the doors. Second traverse will toggle only every other. And if that works, I'm pretty confident the rest will work. And at that point, we're just going to get the answer. Boom, boom, boom. So we're going to go hallway dot traverse 1. So we go to every door is what 1 means. And then we're going to go hallway, traverse, and we're going to go to every other door. And I'm going to assert, I'd probably go build a loop like Ankur helped us with last show. I'm sorry you're not on the show now, Ankur. If you are and I'm not hearing you, you need to give me a stronger signal. I'm looking at comments on LinkedIn and I don't see you, so I'm assuming something serious happened to your internet. Okay, anyways, so traverse 1, traverse 2, let's do an assert. So if this is true, let's model it really quick. All the doors, that's like just 4 doors. They start out all closed. And then the first traverse is going to open all the doors. And then the second traverse, probably make it a little less confusing, put a little space there. We will go to every other door, toggle it, so it should be this, like that. So my answer should be that assert true that the first door is false. False means closed. And hallway.to array sub 1 or sub 0. Hallway. Boom! All right, and I gotta spell some things correct. Assert.true. Hallway, the next one will be true. And the next one after that will be false. 0, 1, 2. And then the fourth one, or the third element, will be true. Cool, let's run this and see if it passes. And if it passes, we're ready to run the full deal and see if we can get the answer. Compilation error. All right. And let's see, all the semicolons are there. Oh, I closed. The asserts. Well, I guess I should actually read the error. True, Boolean, string, parameters. Those should be returning Booleans, so it should be okay. Why is it trying to, did I put quotes on it? No, that's weird. Oh, I'm being redundant. True is true. I may have gotten a Slack from someone. Let me check and see that's Encore after I type this code in. Okay. I did get a Slack. Fixing some internet issues, we'll be back. So Encore is facing. The internets weren't kind to him today. Okay, all right, failed. Hallway test, I expected false, but was true. Okay, so one of the negatives to this is we don't know what line that was. It doesn't give us line numbers, so I have to like enter in more information to know which one failed, which is interesting, that one failed. Toggle twice. Traverse once. I like the name of this. Actually, the outcome is toggle every door, then toggle every other door. And if I want to be communicative, I can say I'm testing the traverse API. Okay. All right, so got to put some information in here because we don't know. This is index 0. Index 1. Index 2. Oops. Index 3. All right, let's see which one of those babies failed. Oh wait, yeah, it should be okay. Traverse, false, true, false, true. Index 0. Expected false, but was true. All right, well, that's interesting. It expected to be false, but it was true. So that means hallway traverse. So the doors all start out closed. Maybe my model's wrong. Oh yeah, I think my model's wrong. No, the doors all start out closed. And maybe I should do this. Then I toggle them once. And then I toggle every other. Oh yeah, I think I modeled it poorly. Okay, so that's what it should be. It should be not what I did. Whew. Did the opposite. Yes, if your model's wrong, then everything's messed up. True, false, true, false. Run the test. Got a green ball. All right, so the test passed right there. Got a green ball up there. Now, one would say, Lance, why don't you write a test for 100 run traverse 100 times, incrementing the number of how many doors you'll skip. Well, the problem is I don't know the answer, so I can't write that test. I can assume I know the answer. Remember, I came up with 50% based on some small modeling I did, but I don't have a lot of confidence in it, so I wouldn't write that as a test. So what I'm going to do is I'm just going to put a loop in there, and I'm going to run it, and we'll find out what this program says the answer is, and then we'll go to a higher authority. That's usually Malibu and David Kuntz. They're not here today, but they already told us they think it's 4 doors. So if I get 4 doors, hey, David gets to go home and spike the football when I let him know that he won. All right, so here's how we'll run the loop. We'll add another test in here. Oh yeah, well, if I wanted to test this more deeply, by the way, I could do another loop like this. But I'm pretty confident it works because we've tested so many of the little pieces. But if I had any doubt, I would just copy this. Oh, what the heck, let's do it. I don't have anybody here to stop me today. And then we run it from 0 to 99. And our loop conditions will be every 1, or every 2 in this case. And the first door will always be true. And the second door will always be false. So every odd door, true, every even door, false. And we don't need this line. Okay, we can try this one out too. Now this is a case where I might spend more time debugging my test than the value I get from it in this case, because it's if I don't craft it right, it will yell at me. So it looks right. Like it's going to go every 2 doors, and it expects for every 2 doors, the first door will be true. The second door will be false. I'm glad I wrote this little cheat sheet here, otherwise I would forget what I'm trying to do. All right, let's run it and see. Green ball. All right, so there. It's comprehensively tested that array. But if I had to test 1 million or 5 billion, I probably wouldn't bother. I would be happy as long as my smaller set is correct. That doesn't work for everything in the world, but I think it will work for this type of sequence. And there's a math person out there who could probably prove what I'm saying is true. Okay. Anyways, let's go ahead and delete this. Okay. Here we are. So we're gonna run it. We're gonna get the answer, folks, right here in what time do we have? We're halfway through the show. This is a good spot to let's get the answer. 100 doors. What's the answer? This would have been like if I had a time machine, I could go back. I could win so many math duels with famous mathematicians. You had to do it the hard way. They derived it from first principles, and me being not smart enough to do that, just write a computer program to model it and then tell them the answer. And then they would say, how did you derive that? And I would say like, I'd have to wave my hands and say, I got the answer though. It's like when you're in school and you're supposed to show your work, but you only show the answer. You always got in more trouble when you did that. At least that's what's going on with my daughter right now. She doesn't like to show her work. She does it in her head, writes it down, and then she gets it wrong. I'm like, I don't know what you did here. Or if she shows me her steps, then I know. If the steps look right, then I assume the answer's right. I don't have to work so hard. I don't have to compute it. I just look at the steps. Okay, so anyways, here, we're gonna write it as a test. Let's put it at the, let's put this at the top. I don't know, tests are usually written by time. So actually, let's go to the end. That might be okay. We'll go to the end. I'm gonna talk myself out of that. We'll go to the end. Should be on one end or the other. Let's put it that way. Test. All right, public. Boy, this is a learning test. We're gonna learn what toggling 100 doors looks like. And so we need the loop again. So let's see, we're counting by using integers, and these are different doors. Door number starts at 0. As long as door number is less than, what do we got here? We have a hallway dot to array dot length. As long as it's less than that, keep going, and we just increment the door. Except we're not incrementing doors. This is not correct. So I thought about this as I typed along, and I realized this isn't the right word. We're talking about passes, because every pass through the doors, we're not actually going to every door. We're skipping around. We're doing all kinds of stuff. So this is like how we're stepping. We're stepping. We used the word step by earlier in the show. This is like we step by 1, which means we go to every door. We step by 2, we go to every other, 3, 4, 5, onwards. So it's a step by. If you have a better word, chat it up to me. I'll use it. And it's important to get these words right if you're actually ever going to go back and look at this code again. Otherwise, it just looks like nonsense. You can't figure out what the heck it is. So this source code is documentation for us human beings. Computer doesn't care how well spelled or how well understandable your code is. But if you write it so it's understandable, then other people can maintain it. This is just like I was telling my daughter who go back to her math, and she writes things like, solves part of the problem over here, goes over this part of the page, writes something else, and over here, and then doesn't even bother to cross out this part. And it's like, nobody can follow your steps. You're not documenting your steps. It isn't about the answer. It's about, can you do the steps right? At least that's what it should be in school. Okay, so anyway, step by. We have calculators to do the actual computation. I don't even know if I think I need a curly brace. I just do a traverse. Oops, hallway dot traverse, and we're going to traverse Oh, step by should not start at 1. It should not start at 0, it should start at 1. And step by should go to 99. So if step by increments up to 1 less than the length, 99, that should be okay. I think it's all good there. Gotta always check those boundaries. The word boundary means where you start your loop and where you end your loop. Boundaries, human beings frequently are poor at boundaries. So that's why I double check. And then maybe I still get it wrong, but that's why I have tests to help straighten me out. All right, so this will go through that loop 1 to 99. It just seems wrong. It feels like I should go to, no, it's gonna stop. I see the problem here. Okay. This is supposed to go to 100 then. I keep getting confused. David would say like, see, I told you, you shouldn't be using zero-based arrays. Got to do less than or equal to. Because I actually want to do the 100th step, which is go to the 100th door. Wow, I hope I'm handling that boundary right. So as a software developer, I get nervous about boundaries. I lose my confidence whether it's done right. So you know what? I'm going to pause on this test. Pause on this test. I'm going to comment out that, and I'm going to do a quick test about the 100th. Because what I've learned through experience is if I think of something that makes me nervous, I think, oh, well, I should write a simpler test for it. Because a simpler test is just, let's do a traverse, let's check the 100th door, let's do every other traverse, let's check the 100th door, and see if it worked right. Technically, I did that though. I haven't done a traverse at 99. That's my problem. That's what I'm trying to figure out right now. I'm worried that traverse 99 means I go to the 99th element, which is the 100th, which is not the 100th element. That should be the 99th element. So I need to go to the 100th element. So I believe, see, we got to work this out. So it's a boundary condition test or something. I smell some problem hiding in here. All right, so this is a test. That the test is this, that the 100th door is working properly. The 100th door is toggled. So this test checks that 100th door, 100 door is toggled. Something doesn't. I have a feeling we covered it, but we haven't done a toggle. We haven't done a traverse 99, which means, no, we got to do a traverse 100 because we do traverse at 1, because it means it goes to every door. But now I want to traverse the 100th door, and I just want to toggle the 100th door. All right, we can write this test. You can conceptually see that we start out with all the doors false. We're going to go to the 100th door, and I'm going to toggle it, which means it'll be true, open, and that test should pass, right? Pretty simple. It's simple when you think about it, so just write the test. Or if I did this in this loop here, I'm going to be checking all kinds of crazy stuff. I'm running a loop. So let's write the simple one here. Less complexity. Prove that the simple things work. The simple things, if you can't prove that, then you know you've already got a problem. What's going on here? So, hey, do I hear you there, Ankur? Oh, it's like a Mr. Solopreneur David Koontz has dropped in on us. Hey, let me.
You must have started early. You're already.
Yeah,
coding.
well, did pretty good. The show launched pretty smoothly. And then Ankur joined, so I kind of had to get the camera working, and then his internet stopped working before I got him on camera. So we almost had a smooth launch. Let me add you on. Hopefully, I will remember what I was doing there a moment ago. Let me get you on camera.
I'll remember what you were doing.
I was just about ready to pull the trigger and get the final answer and see if you and Malibu were right. But then I realized I was nervous about something, and I thought about it like, oh, I should test this. So let me see if I can fix. I'm having some transformation stuff happening on my camera. Oh man, I tell you, there's like a mystery of how OBS and all this stuff works. All right, I'm gonna destroy it. You look at the clock, David. See if I can do this in like 2 minutes.
Okay. I've got you on the timer.
Wait a minute. You're actually on camera. How did you do that?
There was a blank space for David Kuntz, so I just plugged myself
Wow. You know what? You're showing up on OBS fine. I was sitting here deleting something, and I can't actually use that now because it'll delete you. So I have to. We're going to stick with this frame.
Okay.
What the heck, man? You're the magic guy. I don't know why Ankur didn't just pop up over there, but
I don't see Ankur anywhere. I didn't see
no,
him
he
yet.
he was there, and then later he, just as I was closing in on the camera problem, his internet stopped working. All right, so you're on camera.
He was
That's all
probably
done.
using Microsoft
So-
Teams.
You did say something about Teams, actually.
So 100th door, you're
We
just
haven't-
gonna set it up and make sure that the 100th door is
Yeah,
toggled.
because I
perfect.
realize I'm not confident that we have that it's a boundary, and then developers are bad at boundaries. And you would say, and I already
Yeah.
played this out for you before you came on, that David would say, Lance, you're thinking about the boundaries of 0 again. This is screwing you up and causing you more toil and grief. So you already argued with me about that and told me, if only the
Yeah.
world were different. And then, so now I'm writing the test for it. So hallway
Okay,
dot traverse.
I'm all in on this because it's going to cause us to have to
Traverse 100.
decide on that.
I don't know if this is going to work because I'm nervous because that's a boundary, right? And did we correctly handle starting from 0 and all of that? Of course, I could look at the code, but that would be cheating. Let's just write a test to make sure it works.
Oh yeah. Oh, okay. I see. So
Assert R equal.
the setup condition will set up our hallway, and then you're going to just jump right
The 100th
into
door.
traversing to the 100th door by step. That's a step by.
Yeah,
100,
you got it.
right?
So what's the answer,
Okay.
David? What should I be asserting that 100th door? What should state be?
It is closed initially. It should now be toggled to open.
All right.
So it should be open.
We agree. Hallway.
So hallway.
to-
How do we do that?
And now it's an array. And now that should pass. And if I had any other thoughts, just in case we got off by one, I'm going to assert false
For 9.
for 98. I can't assert false for 100 because that would just be foolish. It's an array.
Yeah, it would just crash
All right, let's run this test.
because bytes are expensive out here in 1980.
All right, so hallway. I didn't spell something right. Traverse. Oh, it's capital T on traverse. Capital T on traverse. And the name step. I have a step in there somewhere.
The name step, which could probably be step by wherever it is. It was probably in the traverse.
Oh, this is down here. So I was
Oh,
getting ready to pull the trigger and get the final answer, but that's where I realized I felt unconfident about my boundaries because I realized, I'm going to run this. I had to argue with myself about this 100 versus 99 thing. And I'm like, I better write a test.
I wasn't there to help you in an argument.
I did it. I like changed sides of the camera. No, not really. But next time I should have. Wow, somebody sent me a chat. Was that you? Hey, did you start early? I don't think I did.
Yeah. I'm just ragging.
It started smoothly. However,
I'm
the
late.
camera, if it wasn't for the camera, the anchor out would have been perfect. But all right, so
All right.
passed.
So
All right, so
if I read that right, you just got a passing
yeah.
test.
So I think we're ready to pull the trigger on the whole schlemiel.
Yeah. I want to add to this. I think that may be right. That may be all right. But when you do something like traverse by 33, I think we might be off because we did some step-by logic at one
You
point.
think an odd number will be weird? Is that what you're saying?
I'm saying that write another test for traverse 33 and then test the end condition. Do you follow
Like
what
that.
I'm saying?
And then, do you care about the end, or you just want to look through the whole array?
No, 99 needs to be not. So it'll be 99, but that'll actually be the 98th door. And the 98th door should be open.
Okay. Yes, I'm with you now.
And I don't know about the 100th door.
Nothing else gets toggled. I mean, a few other doors got toggled.
I think it'll be false, yeah.
Yeah, we can check.
Yeah, now
We'll surround the door.
riddle me that
That's
one.
supposed to be open. And this would be we could actually completely, I mean, we could do this, assert dot true hallway to array is 33, should be true.
Which will be the 32nd
Oh,
door.
good.
You gotta subtract the 1. I had this conversation with Malibu
Yeah.
and I learned how to do off by 1
And then
error.
66 minus 1.
Yeah. You've got to think about
Do
it.
this.
And you said to me the other day, think about it logically. And I was like, well, how else would I think about it logically? You got to think about it like a regular human and then subtract
Yeah.
1.
That's probably logically. There. How about that?
I love it. I
Go
love
99. I don't know if we need to go. We probably should leave that 98 because we surrounded it. Okay, cool. Let's see. This test should pass. Passed.
True. All right.
Are we ready to break the news whether you and Malibu win the prize for?
Yeah, it's time. It's time to do the whole.
Just to
kit
be
and caboodle.
clear, you two are saying that it'll be 10 doors open, right?
Yeah, that's an affirmative.
How is that Malibu? Is that how you spell Malibu?
Yeah.
All right. There we go. Okay, so we go to this test, not that test. And we're going to turn this baby on. And I was talking to the folks on the internet saying, like, this is a weird case because we can't really assert the answer because we don't know the answer. We're actually going to trust. What we did is we test every little piece of our application in a small set, in a range. And we're going to assume if we do a good job in this small, simple functionality, it will just do its job. And so we're going to run this, and then we're going to, guess what, David? You get, this is your favorite part.
We're gonna do a printout.
Line, all spelt out. If we can, oh yeah, I got to write a loop. Do we have a loop for this already? We probably deleted it.
You're in a loop.
I
4.
probably deleted it. Yeah, I got to build a loop.
Oh.
All right. Let's do this. Let's make a private function. Private.
You've got print array.
Do we have
down
print array?
there.
Oh, perfect.
What
We already
the
did
heck
that.
does
Oh,
do?
some smart guy made a private function already. That's probably Hunker. Let's see here.
Yeah. It was. I think it was with.
We'll give him
Ankur.
credit.
He was. Yeah.
Let's see here.
So,
I lost my spot. We're at, not at this. Let's get that proper. Oh, we're right here. Right here. Okay.
You don't have any brackets in your for statement.
No braces?
Not all
Yeah,
that
the
code
interesting
in
thing is that's not
Braces.
usually required, but I think one of the languages you and I usually work in, it's required. Is that
Oh.
a Swift? There was a new modern language, I think it was Swift, that required it. I was like, what the hell? I'm used to skipping those when I don't need them. Yeah, and then there's other people who are like, how do I say, pedantic about always putting braces everywhere. And I'm like, dude, if you don't need them, you don't need them. It's like, I'm a minimalist. If you don't
Yeah,
need it, you cut it.
Swift will allow you to infer it.
Oh,
and it has a lot of inference, but I don't know about, and if you're not going to do anything in your block, I expect you don't need it. But now you've just opened up a block that you want to do, and it's not going to do the block.
It's just going to do, this is the block.
Okay, you don't want it to do it inside the block. You want your block to be empty, your for block.
No, this is my block. So this is equivalent to doing this.
Oh, I see. Okay, I see the parens.
If I did that.
The parens
Oh, I
have
see.
me. I see what you're doing. Okay.
And I'm not sure Swift will,
And then
I'm not sure Swift, I forgot. There was some modern language that actually forces you to use a curly brace all the time. And I don't recall why. I was somewhat annoyed.
Modern yet old language.
Some invalid arguments. So we got to pass in a Boolean array. Is that not what I did? Oh, I have to pass dot to array. Boom.
Oh, now we have to do a manual count.
Oh, we don't have to,
So we've
David.
got 1,
But this might
we
make it
don't?
more suspenseful and fun though. 1, 2,
1,
3,
2,
4,
3.
5, 6, 7, 8, 9. Are you getting nervous, David? Dude, you nailed it! You and Malibu nailed it! I told the audience, now you got to go out and spike a football on the show. Like, you nailed it, bro! Wow, sweet.
The programmer equivalent of spiking a football is opening a beer.
It's the spray gets on the camera. That's the really good one. Wow, dude! Congratulations to you and Malibu. You win a prize. I don't know what the prize is, but you won it. Son of a gun.
Yeah.
That's awesome, man.
All right.
Wow, I don't know what to.
All that
We're
work.
done.
So now let's compare how many lines of test code to how many lines of
This was a
implementation
wicked
code.
test code 158. I'm just gonna leave the braces in there.
Yeah, 160,
160.
160 lines of
236.
36. What is that a ratio of? Very close to 4,
2/3,
5,
man.
6, 7. That's 7 to 1. I think.
36. I'm sorry. What was that? 160? Oh yeah, you
160.
you're ahead of me on that one. Yeah, I got that wrong. Yeah, it sounds right. That's crazy, but that's not uncommon. It's a weird case. So usually folks it's 50-50, like half of your code is test, half of your code is production code. But in this case, there's a lot of conditions. So, and when I was thinking about looking up the answer for the show so I could at least talk about it, but then I didn't get to it. I found a slide share. See if I can find it again. I may have lost that window. That's not it.
Somebody did a presentation about
Yeah, and it's actually somebody I know too, which was really funny. There it is, a 100 doors Kata solution, and he doesn't say the answer though, so he didn't give me what I wanted.
He doesn't.
So this is a friend of mine from.
Oh,
This is a friend. You know Stephen Mack? Oh, Stephen
Yeah.
and I. He's from Hong Kong. We've worked together at Huawei, and when I was there with Solutions IQ, and he was there with OD, we're doing as a Solutions IQ partner. So, anyways, yeah. So he wrote some code in here, and I was kind of like looking at it just before the show, like his attempt to solve the 100 doors kata, and he's got it on GitHub.
Okay. And he doesn't say what. he
Yeah, no,
came
that's
up
the
with.
irony here. He says problem. He talks about the problem, and spoiler warning: you may not want to continue if you haven't done this kata before. I don't think there's much
We've
spoiler
done
here,
it.
but anyways, so he's using I think Jasmine. So this is in JavaScript. So all doors close at the beginning. So he's saying like he's instantiating a door list and iterating. Now, iPairs, I'm not familiar with that. Maybe that's a function. I don't know. He's not here to explain it, but and then he used and then this is his implementation. So he calls it a round. He passes in a round, and in 1 to number of doors equals 100. Is this JavaScript? I'm pretty sure it is. Turn doors. He never used the variable here applied because he's going to test drive it. What was he apologizing down here? Oh, for global variables. The second test. So he's probably doing step by like we did. For I to door. Oh, I see what he's doing. I don't think he wrote the code the same way we did. Like his loop, our loop is in our product and his loop is in his tests. Is that what's going on here? Or no, he's checking. Okay, he's checking. So this loop is to check. And I don't know what iPairs does. It's probably a JavaScript function I'm not familiar with. And it's asserting that it's true. So when he calls doors 1, I guess that means, well, it says all doors open after first round. So doors is his, this is a function call. and it returns an object with local. This is not seeming like JavaScript to me. What the heck language is this? I don't think, but it is Jasmine. Maybe it's
my guess is he's got.
So I think local's weird. I don't know. Maybe this is he wrote this a few years ago, so maybe this is a different version of JavaScript than I'm familiar with. I never used local in my life. Let's see here. So now he's doing
Extract door to its own.
Oh, initialization. So so he initializes the doors. Now he gets the doors. If round is equal to 0, then just exit. Oh, so I'm in the product code. And yeah, that's weird. He's not showing the test, is he? No, he's not writing initialize. Oh, okay. Maybe he can't. In order to pass his test, he has to initialize it. Maybe that's the idea. That's probably the idea.
Don't know.
Okay, I think that's the idea. I was going to give him a hard time that he's not test driving, but as far as I can tell, he is. And now he's doing from 1 to number of doors. And what does this mean? I don't know. I is equal to 1 to number of doors, comma, 2, do assert true. I'm a loss on that syntax. I don't know. And that was let's fake it for now, as if I know the solution. I equals +1 mod. So he's getting his rounding. So he's trying to solve that rounding problem that we did. And he's using mod. So mod means, I don't know if you're familiar with mod, but okay.
Yeah.
So if it's, so he's saying if there's no,
It's integer division.
if there's no remainder, then I think that's what this should be doing, is if there's a remainder, this returns the remainder. Or I've forgotten my mod function. It's been a while.
Yeah, mod returns the remainder.
Okay, cool. And it returns 0 if there's...
Whereas integer division returns the mantissa.
Okay. David, I count on you to know all the fancy terms here, bud. Mantissa, nice. Fourth test. Get a piece of paper and do some math. I don't know what this is about. Anyways, he probably had said, screw it, I'm going to do some modeling.
Yeah, I did that.
And then I don't know where he goes here. I didn't really look at this closely. And that's okay. I was just curious what he did, what somebody else did, especially if I knew who they were. So here's his, I'm assuming he's getting close to a solution here. So he does round, and then I should open in, should open in, then, yeah, I think his algorithms look quite a bit different. We don't have it. Oh, we haven't, do we have an if? We don't have any if conditions in our code. I don't recall any. Oh, because we have it,
Oh, that's it. That's his. He's going to calculate the factorial issue. There should open in round. He's calculating whether it should be opened. And if it is, then he sets it to true.
So he goes to every door where we actually skip. So yeah.
We skip because we
So
do a
ours will
step
run a
knock.
little bit faster. Did you hear that, Stephen? Ours will run a little bit
Just
faster
like-
because we don't go to every element. We
just
skip.
like a
we only
programmer.
cover the elements you need to. Of course, somebody's going to do another show about our solution and come up with better ways.
Oh yeah, and they'll
They'll realize it's the best way. That's what they'll realize.
yeah, they will. I mean, it just goes without saying.
Cool. Yeah. So Stephen Mack, yeah, he's in Hong Kong. Cool, very cool guy. He runs Agile Hong Kong. I don't know if he runs it, but he's one of the organizers. That's probably close to
All
running it.
right.
Well, what else do we have to say about this, David? We're done.
What's the next problem we're solving?
I think, we could talk about what to do on the next show. So let's have a discussion, meaning I don't know how you feel and what the answer is. Ankur, so Ankur's not here, but I'll tell you what Ankur was thinking about. Ankur wants to do something related to data structures, and I don't have I need to talk to him and see what more he means. And so maybe the next show he says he wants to talk Monday. So maybe the next show after our conversation is we talk about data structures in .NET. So that might be more of like ideally there'll be code involved, but there might be more of a conversation in design. Which I remember you did a show on design when we were doing the baseball kata, which I think was really cool. Is you helped fill in the knowledge part. Sometimes people get all focused on the coding part without.
That's cool. The data structures was what Ankur was interested in. Data structure I'm having trouble with right now in my side project is a stock management.
You have so
app
much
where
money
you-
in stocks now. You have to have you have to write an app to manage it.
I have to write my own app because nobody else does it right. And they obviously didn't write it test first, or they yeah. So the fact is, you can buy tons and tons of apps that do all kinds of watch list management and everything, but none of them graph your own buys and sells on the charts that they graph. And I don't care what the stock did. I care what my buy and sell did in the stock. And so that's what I'm trying to do. And right now, oh my goodness, dealing with, I swear the API I'm using, I swear they toggled, and they used to do time traveling backwards in time, and now it's time traveling forwards in time. And I wish I had, captured code and. Yeah,
So the problem solution is you want to know about your positions in time, going to the, okay, and how well they did rather than just the stock in general?
Yeah.
Yeah, it's a pretty rational thing to want, because I noticed too that the decisions I want to make shouldn't be about, the stock's going up or down. It's about when I bought it like 5 or 6 years ago or whatever, how many years ago, did I make any profit or not? Do you think that?
Yeah, from that buy.
And I'm surprised that none of the apps are very good at that. I kind of think the one I use is to a point. The thing is, it doesn't. So if I buy some stock on 10 years ago, and then I buy the same stock 5 years ago, it doesn't track that. It won't know my positions. I think. I don't know what it does. Is it just pick the most recent purchase position and then forgets about the 5 years ago one?
I don't know.
So how do professional traders do this?
Name that app.
Sorry, name it. It's
Name that
Ameritrade,
app.
bro.
Ameritrade. I don't know
Oh.
that. I have tried all kinds of apps on the internet, and I use E-Trade as my broker, and I've used Merrill's stuff, and I've used a couple others in the past, and I'm all like, none of them care about me, the consumer, and whether I'm making money.
I think you're right. It's like they're perpetuating short-term thinking because you get excited about the stock climbing and like, oh, maybe I need to buy or sell. And then the question is like, well, what did I actually pay for this bloody thing? And then you want to look at the position, which Ameritrade will show your positions, except for the scenario I said where if you buy more stock, you don't know your position anymore. It won't show that to you.
It doesn't know how to aggregate, which is a simple math problem.
You might be onto something here. Are you saying that if nobody's did this, and then there's clearly a need in the market? Because
don't tell everybody, Lance. Oh my gosh, you're going to put it out there on the internet. Now everybody knows.
Yeah, it's too bad. There's like 1 million people watching the show right now that are all developers.
I know. I should have had you do that NDA.
Yeah, right. Shoot.
Yeah.
Well, that's an idea.
There it is. My good idea.
So, David, this might actually be closer to what I want to do. So there's what Ankur wants to do. David just talked about what he was thinking about. And then what I want to do is write something that's full stack in .NET. And that means web page, something in the middle. I'm pretty happy once I get to the middle. I don't know if there needs to be another thing on the end. So if you're saying, like you and I, we could, if you're saying, we could use your idea to build this. I know it's not in the language that you want to support, but maybe it's a good practice for that.
Yeah, and not in the right language there, buddy, because you can't get that C# stuff to run on an iPhone.
Is that really true? It's true close enough. Let's call it that. You know, you could probably struggle and get it in Mono running on iOS because Mono runs on Unix systems and it runs on Mac too.
I don't know what a
Mono's the
is.
runtime is the .NET. Yeah. .NET runs in what's called, it doesn't have a JVM, Java Virtual Machine, because it's not Java, right? So it has what's called a CLR, and I forgot what that stands for now. It's the Common Library Runtime, maybe? Something like that. Clear, CLR. And the CLR runs on, of course, natively on Windows, and then some people ported it back in the 2000s onto, like 2006 maybe, onto Linux. And some people in Redmond. I don't know what big company that was. And then now it's still running around out there. That's why we could even do this dojo, because it's .NET runs on, C# runs on in Mono inside this Docker container. Yeah. Well, cool. So we need to like work out what we're going to do, and then have a show on Tuesday would be my goal.
That works. I'm game. I enjoy hanging out with you, Lance.
Well, thank you, David. It's awesome working with you too, and arguing about zero boundary, one boundary. All right.
Yeah, I wrote a whole blog post about that on the Swift Dojo. So
you tried to bring back Fortran, bro.
Fortran's the new language. It's going to come out. Fortran 2025.
I wouldn't doubt it, man. It's still a language that people support and use. It's crazy. Well, hey folks, we're gonna go ahead and drop. But if you want to do this Doors Kata Dojo on your own and you're not sure how to get started, go back to episode 1 that you will find on YouTube or LinkedIn. I don't know if LinkedIn ever archives the old shows. If it doesn't, go to YouTube and it'll be there. I don't know. Anything else, David?
Have fun. Remember to write your test first.
Yeah, write your test first. All right, let's close the show. This isn't as much fun as the X, but anyways.